Hello, in this lecture we will find out the radius of a circle. In the drawing we have a circle. Inside this circle we have chord DB, that is equals to 2 units in its length. We have also chord AC, that is equals to the square root of 2 units in its length. And we have also, this is angle DAB, that is equals to 45 degrees in its size. Again, our mission is to find out the radius of this circle. So first of all, we'll join points A and D together by a straight line. By joining points A and D, we created there peripheral angle DAB. This is peripheral angle DAB, and peripheral angle DAB subtend on chord DB. We define the size of this peripheral angle DAB as x over 2. So peripheral angle DAB subtend on chord DB, and the size of peripheral angle DAB is x over 2 according to our definition. In the next step, we define the center of this circle. This point is point O. We will join points O and D together by a straight line. Likewise, we join points O and B together by a straight line. Actually, by doing this construction, we created here certain angle BOD. This is central angle BOD, and central angle BOD subtend on chord, the same chord, chord BD, exactly as peripheral angle DAB. Okay, so here we can implement rule 13. I'll repeat quickly on rule 13. According to rule 13, a central angle is twice as big as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB. The size of peripheral angle ACB is theta, and peripheral angle ACB subtends on chord AB. In addition, in the drawing we have also central angle AOB. Central angle AOB subtend on the same chord called AB. And therefore, according to this rule, rule 13, the size of peripheral angle AOB, or the size of the central angle AOB, must be twice as large as the size of this peripheral angle ACB. Why? Because of the fact that those two angles, they both subtend on the same chord called AB. So because of the fact that the size of peripheral angle ACB is theta, then the size of the central angle AOB that subtend on the same chord called AB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have peripheral angle BAD. This is peripheral angle BAD. The size of peripheral angle BAD is x over 2, and peripheral angle BAD subtend on chord BD. And we also have the central angle BOD that subtend on the same chord called BD. Therefore, according to rule 13, the size of this central angle must be twice as large as the size of this peripheral angle, because both those two angles subtend on the same chord called BD. We know that the size of peripheral angle BAD is x over 2, therefore the size of the central angle must be equal to x. Okay. We will define the size of peripheral angle CDA. This is peripheral angle CDA is y over 2. Again, the size of peripheral angle ADC equals to y over 2 according to our definition. In the next step, we join points O and C together by a straight line. Likewise, we join points O and A together by a straight line. By doing this construction, we can deduce central angle COA. Central angle COA subtend on chord AC, exactly like peripheral angle CDA, it is also subtend on chord CA. And therefore, according to rule 13, the size of central angle AOC must be twice as large as the size of this peripheral angle ADC. Why? Because of the fact that those two angles they are both subtend on the same chord called AC. The size of peripheral angle ADC is y over 2. Therefore, the size of the central angle AOC that subtend on the same chord called AC must be equal to y. In the next step, I will copy triangle DEA, this triangle DEA in a new page, and we will implement rule 4 on this triangle, triangle DEA. So actually, this is triangle DEA, the code from the original drawing. This triangle DEA, those two angles plus this angle, they are both defined as interior angles, and this is angle DEB, that is defined as an exterior angle of this triangle, triangle AED. Why? Because of the fact that this is angle DEB, it is located outside triangle DEA, and therefore it is defined as an exterior angle in relation to this triangle, triangle DEA. Likewise, those two angles, they both are located inside triangle DEA, and therefore they are defined as interior angles. And this angle AED, is also an interior angle. Again, angle DEB is an exterior angle of triangle DEA. So in the next step, I will present to you rule 4, and we'll implement rule 4 in our drawing. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles A, B and C. Those three angles are all defined as interior angles of this triangle. Right, this is angle E that is defined as an exterior angle. Why? Because it is located outside this triangle, while those two triangles A, B and C, they are all located inside this triangle, and therefore they are defined as an exterior angles, and this angle E, is defined as an exterior angle in relation to this triangle. And according to this rule 4, the size of the exterior angle E is equal to the sum of the two interior angles that are not adjacent to it. Here we have three interior angles, A, B and C. This is angle C that is adjacent to this angle E. And the two angles that are not adjacent to this angle E are A and B. And the sum of those two angles is A plus B. And therefore, according to this rule 13, the size of this exterior angle E equals to A plus B, because A plus B are the two interior angles that are not adjacent to this angle E. So in total, we should find out that the size of this interior angle E equals to A plus B. Those two angles A and B, they are both interior angles that are not adjacent to this angle E. So in conclusion, we found out that the size of the interior angle E is equal to A plus B, and A plus B, there are two interior angles that are not adjacent to this angle E. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have here a triangle ADA. Those triangles 1, 2, 3, they are defined as an interior angles because they are located inside the triangle, while this angle BED, the size of angle BED is 45 degrees. Angle BED is defined as an exterior angle, why? Because it is located outside triangle DEA. And according to rule 13, the size of this interior angle BED equals to the sum of the two interior angles that are not adjacent to it. This is angle DEA, and the angle DEA is adjacent to this angle BED, and the other two interior angles that are not adjacent to it are y over 2 and x over 2. And according to rule 13, the size of this exterior angle BED is equal to x over 2 plus y over 2. So write it down. According to rule 4, of course, according to rule 4, the size of this exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA that is adjacent to this angle DEB, and the two other angles that are not adjacent to angle DEB are y over 2 plus x over 2. So the size of the external angle DEB is equal to the sum of the two internal angles that are not adjacent to it. That is to say it is equal to x over 2 plus y over 2. Okay. But it is given as a question that the size of angle DEB is 45 degrees. So we substitute angle BED by 45 degrees. So 45 degrees equals to x over 2 plus y over 2. Here we will multiply this equation by 2, and we get that 2 times 45 degrees is 90 degrees, equals to x over 2 times 2 is x, plus y over 2 times 2 is y. So if we should find out that x plus y equals to 90 degrees, we subtract x from this equation, and finally we get that y, this will be equation 1, y equals to 90 degrees minus x. And again, according to equation 1, we should find out that y equals to 90 degrees minus x. In triangle DOB, actually side OB is the radius of this circle. Why? Because it starts from point O, that is the center of the circle, and then at point B, that is the point on the circle itself. This is exactly the definition of a radius. Therefore, OB is the radius of the circle. The radius of the circle is the radius that we are looking for in this question. We define the radius of the circle as R, therefore OB equals to R. Likewise, OD is also the radius of the circle, that is equal to R. Likewise, OC is also the radius of the circle, is equal to R. And finally, OA is also the radius of the circle, that is equals to R. In the next step, I will present to you the law of cosines, and we will implement the law of cosines in this triangle ODB. First of all, the law of cosines is true in any triangle. So this is triangle ABC, that could be any triangle. In triangle ABC, the side of the length of side AB is A, side AC equals to B units in its length, side BC equals to C units in its length, and this is angle BAC. The side of angle BAC is theta, and according to the law of cosines, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. In the next step, I'll copy we'll copy triangle BOD. This is triangle BOD. And then we will implement the law of cosines in this triangle BOD. Side DB equals to 2 units in its length. OD equals to R, it is the radius of the circle. OB also equals to R, it is the radius of the circle. So actually, this is triangle DOB, that the going from the original drawing, and this is angle X. So this is angle X. Again, OD equals to OB equals to R, that is the radius of the circle, and side OB equals to 2 units in its length. According to the law of cosines, according to the law of cosines, in triangle DOB, cosine X equals to R squared plus R squared minus 2 squared, that is 4, so it is minus 4, divided by 2 times R times R. So actually found out that according to the law of cosines in triangle DOB, cosine X equals to R squared plus R squared minus 4 over 2 times R times R. R squared plus R squared is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 4 divided by 2R squared. Okay. So here we have 2R squared over 2R squared is 1 minus 4 times 2R squared. So it is 1 minus, here we divide both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in conclusion, we should find out that according to equation 1, cosine X equals to 1 minus 2 over R squared. In the next step, I'll copy triangle AOC. This is triangle AOC in a new page, and we will implement the law of cosines in this triangle, triangle AOC. Side AO equals to R, and side OC also equals to R. Side AC equals to the square root of 2 units in itself, according to what is given in the question. And this is again AOC. The size of again AOC is Y. So actually, this is triangle AOC that is copied from the original drawing. So in the next step, we will implement the law of cosines in this triangle, triangle AOC. According to the law of cosines, in triangle AOC, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is minus 2, divided by r squared plus r squared. So cosine y equals to r squared plus r squared is 2r squared. So in total, in the numerator of this expression, we have 2r squared minus 2 divided by over 2 times, in the numerator we have over 2 times AB, so it is over 2 times R times R. Over 2 times R times R. It is 2 times R times R. 2 times R times R is 2R squared. So in conclusion, we have found out that cosine y, this will be equation 2. According to equation 2, cosine y equals to 2r squared minus 2 over 2r squared. 2r squared over 2r squared is 1. So we have here 1 minus 2 over 2r squared. So cosine y equals to 1. Here we divide both the numerator and the denominator of this expression by 2, and we get that minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in conclusion, we shall find out that according to equation 2, cosine y equals to 1 minus 1 over r squared. But we already found out that y equals to 90 degrees minus x. We found out that y equals to 90 degrees minus x. So now we can substitute y in this equation 2 by 90 degrees minus x. We will do it now, and we get that according to equation 2, we have cosine y, and y is 90 degrees minus x. 90 degrees minus x equals to 1 minus 1 over r squared. So according to equation 2, we have found out that cosine 90 degrees minus x equals to 1 minus 1 over r squared. But we actually have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. And according to this trigonometric identity, you can substitute cosine 90 degrees minus x in this equation 2 by sinus x. Okay? Because sinus x equals to cosine 90 degrees minus x. So we substitute cosine 90 degrees minus x in this equation 2 by sinus x. We do it now, and we get that according to equation 2, cosine 90 degrees minus x is sinus x, and it is equals to 1 minus 1 over r squared. This is according to equation 2. Well, according to equation 1, we have already found out that cosine x equals to 1 minus 2 times minus 2 over r squared. So we have here two expressions for sinus x and cosine x. Here we have the trigonometric identity. It states that sinus square x plus cosine square x is equals to 1. So we use this trigonometric identity here, and so we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, and here we substitute cosine x in this trigonometric identity by 1 minus 2 over r squared. We do it now, and we get that this way we create the equation 3, and according to equation 3 we have sinus square x. Sinus x equals to 1 minus 1 over r squared, and therefore sinus square x will be equal to 1 minus 1 over r squared plus cosine square x. Cosine x equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared, and it is equals to 1. So we found out that according to equation 3, one minus 1 over r squared plus 1 minus 2 over r squared equals to 1. Here we will define t equals to 1 over r squared according to our definition. Now we can substitute 1 over r squared in this equation by t. Here we can multiply 2 by 1, because whenever you multiply something by 1, you don't change the value of the expression, so we multiply it by 1, and we get that according to equation 3, we have here 1 minus 1 over r squared. 1 over r squared is t, according to our definition, therefore we substitute 1 over r squared in this equation 3 by t. So it will be 1 minus t squared plus, we have here 1 minus 2 times 1 over r squared. So it is 1 minus 2 times, and 1 over r squared is t squared equals to 1. So I shall found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. Here we'll open the brackets on this side of this equation 3, and we get that according to equation 3, we have here 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared, minus 2 times 1 times t, that is minus 2t, plus, again, 1 plus t squared, in total equals to 1 plus t squared minus 2t. We have also here 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 1 times 2t is minus 4t, equals to 1. So in total, we found out that the value of this expression 1 plus 2t squared is equals to 1 plus 2t squared minus 4t, and all equals to 1. So we actually found out that we have here 1 on both sides of the equation, so 1 will get cancelled, after we cancelled 1, in this side of the equation we have, of equation 3, we have t squared plus 4t squared is 5t squared. We have also minus 2t minus 4t is minus 6t plus 1 equals to 0. So if you found out that 5t squared minus 6t plus 1 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c divided by 2 times a. Another specific quadratic equation, that is to say, this is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. The only thing that is left to do is to put the data of our specific quadratic equation, this data inside this formula for x, and this way we find out the value or the values of t, because x equals to t. So we do it now, and we get that again x equals to t, so we substitute x by t. So x equals to t, and it is equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. a is 5, so minus 4 times 5 is minus 20, times c. c is 1, so minus 20 times 1 is minus 20, divided by 2a. a is 5, so 2 times a is 2 times 5, this is 10. So inside the root we have only 36 minus 20. So we found out that t equals to 6 plus minus. Again, inside the root we have 36 minus 20, that is 16. So it is square root of 16 divided by 10. So here, if we found out that t equals to 6 plus minus, and the square root of 16 is 4 divided by 10. So here we have two solutions that are possible for t. So according to the first solution for t will be equal to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1. But according to our definition, t equals to 1 over r squared. T equals to 1 over r squared according to our definition. Therefore, we substitute t in this equation by 1 over r squared. And we get that 1 over r squared equals to 1. Here we multiply this equation by r squared. And finally we find out that r squared equals to 1. R squared equals to 1. Here we take a root out of this equation. And finally we get that the radius r that we are looking for, r equals to the square root of 1, that is 1. So r equals to 1. So I should find out that according to the first solution for t, the radius of this circle, that is the radius that we are looking for in this question, the radius of this circle is equal to 1 unit in its length. But actually it is impossible that the radius of this circle is equal to 1. Why? Because of the fact that we have here chord dB is equal to 2 units in its length. So chord dB is equal to 2 units in its length. And it is very clear that chord dB is not the diameter of this circle. Again, chord dB is not the diameter of this circle. And we know that the diameter of any circle is the longest chord in the circle. Again, the diameter in any circle is the longest chord in the circle. The diameter of this circle is 2r. So the diameter of 2r must be greater than dB, because dB is not the diameter. Because of the fact that dB is not the diameter, and the diameter of 2r is the longest chord in the circle, it means that the diameter of dB, the diameter of 2r, must be greater than dB. This is not the diameter. Therefore, the diameter 2r must be greater than dB. This is not the diameter. And dB equals to 2. And from this inequality, we will derive that 2r is greater than 2. Here we will divide this inequality by 2. And finally we get that the radius r of the circle must be greater than 1. If the radius r must be greater than 1, the radius r cannot be equal to 1. So we cancel this solution, and we left only the second solution for r. That is actually the second solution for t. The second solution, here we have two solutions for t. And the second solution for t is t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So we should find out that t equals to 1/5 from one side, but from the other side, according to our definition, t equals to 1 over r squared. So I can substitute t in this equation by 1 over r squared. We'll do it now, and we will get that t, that is 1 over r squared, is equal to 1/5. So if we found out that 1 over r squared equals to 1/5, we first multiply this equation, and finally get that 5 equals to r squared. Here we take a root out of this equation, and we get that the radius r that we are looking for, the radius r of the circle, that is the radius that we are looking for, it is equal to either the square root of 5 units in itself, or in terms of numbers, it is equal to 2.236 units. Okay. It again, if we found out that the radius r of this circle, it is equal to either square root of 5 units in itself, or in terms of numbers, it is equal to 2.236 units. So we finish with the question. Next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. So in the drawing, we have a circle. Inside the circle, we have chord AC that is equal to the square root of 2 units in itself. Chord DB equals to 2 units in itself. And this is angle DEB. The size of angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we joined points A and D together by a straight line. Again, we joined points A and D together by a straight line. By joining points A and D, we created peripheral angle BAD. This is peripheral angle BAD. We define the side of this peripheral angle BAD as x over 2. This peripheral angle BAD subtends on chord DB. Again, this peripheral angle BAD subtends on chord DB. In the next step, we defined the center of this circle. This point is point O. Then we join points O and D together by a straight line. Likewise, we join points O and B together by a straight line. By doing this construction, we created here central angle BOD. This is central angle BOD. And central angle BOD subtends on chord BD. Exactly like peripheral angle BAD, this is also subtend on the same chord called BD. And therefore, we can implement here all 13. Repeat quickly on all 13. According to rule 13, a central angle is twice as big as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have this is peripheral angle ACB. The size of a peripheral angle ACB is theta, and this peripheral angle ACB subtends on chord AB. Likewise, in the drawing we have also the central angle AOB that subtends also on the same chord called AB. And therefore, according to this rule 13, the size of the peripheral angle AOB must be twice as big as the size of the peripheral angle ACB. The size of peripheral angle ACB is theta, and therefore the size of peripheral angle AOB must be equal to 2 theta. So we can actually implement rule 13 in our drawing. Why? Because in our drawing we have this is peripheral angle BAD that subtends on chord DB. The size of peripheral angle BAD is x over 2. And we also have central angle BOD. This is central angle BOD that subtends on the same chord called DB. And therefore, according to rule 13, the size of central angle BOD must be twice as large as the size of the peripheral angle DAB. Why? Because of the fact that those two angles they both subtend on the same chord called DB. And therefore, the size of the peripheral angle must be twice as big as the size of this central angle must be twice as big as the size of this peripheral angle, and the size of this peripheral angle BAD is x over 2, and therefore the size of the central angle BOD that subtends on the same chord called BD must be equal to x. Okay? According to rule 13, of course. In the next step, we defined the size of peripheral angle ADC as y over 2. Then, from the center of this circle, that is to say from point O, we join points O and A together by a straight line. Likewise, we join points O and C together by a straight line. By doing this construction, we created central angle AOC. Central angle AOC subtends on chord AC exactly like peripheral angle ADC that is also subtended on the same chord called AC. And therefore, according to rule 13, the size of the central angle AOC must be twice as large or twice as big as the size of this peripheral angle ADC. Why? Because of the fact that those two angles they both subtend on the same chord called AC. And the size of peripheral angle ADC is y over 2. Therefore, the size of the central angle AOC must be twice as large as the size of this peripheral angle AOC. And because of the fact that the size of peripheral angle ADC is y over 2, and therefore the size of the central angle AOC must be equal to y. Okay. according to rule 13, of course. In the next step, I copied this triangle DEA, copied this triangle DEA in a new page and implemented rule 4 in this triangle DEA. Actually, this is triangle DEA, the code from the original drawing. This angle equals to y over 2, this angle equals to x over 2, and this is the XO angle in relation to triangle EDA. Angle DEB is an XO angle, and the side of the XO angle DEB is 45 degrees. Okay, now we can implement rule 4 in our drawing. So I'll repeat quickly on rule 4. According to rule 4, the XO angle of a triangle is equals to the sum of the two interior angles that are not adjacent to it. So in the drawing, we have this triangle. Inside this triangle, we have three angles A, B, and C. All the three angles A, B, and C are defined as interior angles of this triangle. Why? Because they are located inside the triangle, while this is angle E, that is defined as an external angle. Why? Because it is located outside the triangle. And according to this rule 4, the size of the external angle E, the size of the external angle E, is equal to the sum of the two internal angles that are not adjacent to it. This is angle C, it is an internal angle that is adjacent to angle E. And therefore the two other angles that are not adjacent to this angle E are A and B. And the sum of the two angles is A plus B. So according to this rule 4, the size of this angle E will be equal to the sum of the two internal angles that are not adjacent to it. That is to say, it is A plus B. So according to rule 4, the external angle E equals to A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have this is triangle EDA. Inside this triangle EDA we have those three angles. Those three angles are defined as interior angles. And we have this is angle BAD, that is an external angle. And the size of the external angle BAD is 45 degrees. Now according to rule 4, the size of the external angle BAD is equal to the sum of the two internal angles that are not adjacent to it. This is angle DEA, that is adjacent to angle BED, and the two other angles that are not adjacent, the two other angles that are not adjacent to angle E, to angle BED, are y over 2 and x over 2. And therefore, according to rule 4, the size of this angle BED is equal to y over 2 plus x over 2. Again, according to rule 4, the size of the external angle BED is equal to the sum of the two internal angles that are not adjacent to it. That is to say, it is equal to x over 2 plus y over 2. But it is given as the question that the external angle BED is 45 degrees, so we can substitute angle BED by 45 degrees. We did it and we actually found out that 45 degrees equals to x over 2 plus y over 2. Here we multiplied this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees, x over 2 times 2 is x, and y over 2 times 2 is y. So we found out that 90 degrees equals to x plus y. Here we subtracted x from this equation, and finally we found out that according to equation 1, y equals to 90 degrees minus x. Okay. In the next step, actually copied triangle DOB in the Olympiad and implemented the law of cosines in this triangle DOB. But before that, we know that DO is the radius of this circle. When you find the radius of this circle as sum, therefore DO equals to 1. Why? Because it starts from the center of the circle and then at point D, that's the point of the circle itself. So therefore DO is the radius, OB is also the radius, CO is the radius, and AO is also the radius, equals to R according to our definition. So I actually presented to you the law of cosines and implemented the law of cosines in this triangle DOB. So if it's quickly the law of cosines, first of all the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. In triangle ABC, this is angle theta. The length of side AB is equals to A units, side AC equals to B units in its length, side BC equals to C units in its length. So according to the law of cosines, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can actually implement the law of cosines in triangle DOB. So I call it triangle DOB in the new page and implemented the law of cosines in this triangle DOB. So okay, this is triangle DOB that are going from the original domain. Side DO equals to side BO equals to R. They are both the radii of the circle. And therefore they are equal to each other. Each of them is equals to R. This is the radius of the circle. Side BD equals to 2 units in its length according to what is given as a question. So according to the law of cosines in this triangle BOD, cosine x equals to R squared plus R squared minus 2 squared, that is 4. That is R squared plus R squared minus 4 over 2 times R times R. Again, cosine x according to the law of cosines in triangle DOB equals to R squared plus R squared minus 2 squared, that is 4 over 2 times R times R. So in the numerator we have R squared plus R squared is 2R squared. So in total, in the numerator we have 2R squared minus 4 divided by 2R squared. Here 2R squared over 2R squared is 1, and we have also minus 4 over 2R squared. Here we divided both the numerator and the denominator of this expression by 2, and we shall find out that 4 minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in total we shall find out that according to equation 1, cosine x equals to 1 minus 2 over R squared. Again, according to equation 1, cosine x equals to 1 minus 2 over R squared. So in the next step, I copied the right triangle AOC, it is not a right triangle, I copied this triangle AOC in a new page and implemented the law of cosines in this triangle AOC. So okay, this is triangle AOC that I copied from the original drawing. According to the law of cosines, this triangle AOC, cosine y equals to R squared plus R squared minus square root of 2 squared, that is 2, divided by 2 times R times R. So R squared plus R squared is 2R squared, so in total in the denominator we have 2R squared minus 2 divided by 2 times R times R. 2 times R times R is 2R squared. So according to equation 2, I shall find out that cosine y equals to 2R squared over 2R squared is 1, and we have also minus 2 over 2R squared. So it is equals to 1, and here we divided both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2R squared over 2 is R squared. So in total, we shall find out that according to equation 2, cosine y equals to 1 minus 1 over R squared. But we already found out that in the beginning of the lecture that y equals to 90 degrees minus x. We found out that y equals to 90 degrees minus x. Therefore, we can substitute y in this equation, equation 2 by 90 degrees minus x. Okay, we did it, and we found out that cosine y, and y is 90 degrees minus x, equals to 1 minus 1 over r squared. So according to equation 2, we should find out that cosine 90 degrees minus x equals to 1 minus 1 over r, to 1 minus 1 over r squared. We have the trigonometric identity that states that cosine 90 degrees minus x equals to sinus x. Again, cosine 90 degrees minus x equals to sinus x. Therefore, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. So if we did it, again, according to this trigonometric identity, cosine 90 degrees minus x equals to sinus x. Therefore, we can substitute cosine 90 degrees minus x in equation 2 by sinus x. We did it and found out actually that again cosine 90 degrees minus x is sinus x, and according to equation 2 it is equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1 we already found out that cosine x equals to 1 minus 2 over r squared. Now we have the trigonometric identity that states that sinus square x plus cosine square x, sinus square x plus cosine square x equals to 1. So now we can substitute sinus x in this trigonometric identity by 1 minus 1 over r squared, so it is equals to sinus x. And we can substitute cosine x in this trigonometric identity by 1 minus 2 over r squared, because it is equals to cosine x. So we did it, and we actually found out we have here sinus square x. Sinus x equals to 1 minus 1 over r squared, therefore sinus square x will be equal to 1 minus 1 over r squared squared. We have also plus cosine x. Cosine x equals to 1 minus 2 over r squared, therefore cosine square x will be equal to 1 minus 2 over r squared squared. And it is equals to 1. According to this trigonometric identity, it is equals to 1. If we multiply this expression by 1, it is allowable to multiply anything by 1, because when you multiply something by 1, you don't change the value of the expression. So we multiply this expression by 1. So now we substitute 1 over r squared in this equation 3 by t. Again, according to our definition, t equals to 1 over r squared. Again, we substitute t in this equation 3, we substitute 1 over r squared by t. So according to our definition, t equals to 1 over r squared. And we found out actually that according to equation 3, we have here 1 minus 1 over r squared squared. 1 over r squared is t squared, plus 1 minus 2, so it is 1 minus 2, and 1 over r squared is t squared. So in total, the value of this expression is 1 minus 2t squared, and is equal to 1. Here we open the brackets on this side of the equation. Equation 3, actually found out that 1 minus t squared equals to 1 squared, plus t squared minus 2t, plus 1 minus 2t squared equals to 1 squared, plus 2t squared, that is 4t squared, plus 2 times 1 times 2t is minus 4t equals to 1. So after we open the brackets here on this equation 3, in this side of the equation 3, in total we found out that one plus t squared plus 2t plus 1 plus 2t squared minus 4t equals to 1. So here we have 1 on both sides of this equation 3, so 1 will get cancelled. After we cancelled 1, in this side of equation 3 we have t squared plus 4t squared is 5t squared, and we have also minus 2t minus 4t is minus 6t plus 1 equals to 0. So we found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we're looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and the coefficient c equals to 1. The only thing that we have to do is to put the data of our specific quadratic equation, this data inside the general formula for x, and this way we find out the values of t, because x equals to t. So x equals to t, therefore we substitute x by t. So t equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6 plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a. a is 1, so minus 4 times a is 5, so minus 4 times 5 is minus 20, times c. c is 1, so minus 20 times 1 is minus 20, so inside the root we have 36 minus 20, divided by 2a. a is 5, therefore 2a is 2 times 5, that is 10. So if we found out that t equals to 6 plus minus, and 36 minus 20 is 16, divided by 10. The square root of 16 is 4. So we found out in total that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So actually found out that we wanted to the first solution for t equals to 1. But according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1. Here we multiplied this equation by r squared, and finally found out that r squared equals to 1. Here we took out of this equation, and finally found out that the values that we are looking for, the values r equals to the square root of 1, that is 1. But it is actually impossible that the radius r of this circle equals to 1. Why? Because of the fact that we know that chord dB equals to 2 units in its length. Again, chord dB is equals to 2 units in its length, and chord dB is definitely not the diameter of this circle. Again, chord dB is definitely not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. And the diameter of this circle is 2r. So 2r must be greater than dB, that is not the diameter. Again, 2r, the diameter of 2r must be greater than dB, that is not the diameter. Repeat again. The diameter of the circle that is 2r must be greater than dB, that is not the diameter. But dB equals to 2, so we can write it that dB equals to 2, and for this inequality, we will derive that 2r is greater than 2. Here we divided this inequality by 2, and finally found out that 2r over 2 is r, and 2 over 2 is 1. So in conclusion, we found out that the radius r of the circle must be greater than 1. If the radius r must be greater than 1, the radius r cannot be equal to 1. So we cancel this solution, and we have to leave the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t equals to 1/5. But according to our definition, t also equals to 1 over r squared. So we can substitute t in this equation by 1 over r squared. So we did it, and actually found out that 1 over r squared equals to 1/5. Here we cross multiply this equation, and finally found out that r squared equals to 5. Here we took out of this expression, and finally found out that the radius r of this circle is equals to either square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units in its length. Okay? Thank you very much.